Okay, welcome back, bro. It's weekly report 5, I believe. Week 5. Thinking about multiple stages. So this is one stage, I would say, or one catalyst, bedding. Basically, I have a transformer, so TR transformer that converts 230 volts into it's like variable. It can be set into 32, 24, 12, 9 and 6, 12 and 6. So basically those I am using the 6 volts. This is AC, obviously. So the here and this side there is like the heating element that is connected to this. So basically this is the 6 plus 6, this is the 0. So I've been tinkering with this, and I have came up with an idea that I will use 2, but if I use 2, then I would draw up too much current because of the conversion of the basically the stepping down of the volt from 230 to 6 is like, if you can quickly calculate it, the 12 would be 20. This is more than 40 amps of power, or 40 amps of amperage at like 1 amp. That's a bit lot. So the current one that I'm using is 140-ish watts of power. I have made them from basically like 316L stainless steel welding electrodes. Basically these are 2 millimeters in diameter. I have made them from stainless steel, and this was the winder. There were like these screws that were holding it to a piece of plywood, but this works like in a fashion that you put the wire here, you pull it through this hole, you pull it out, you pull it along here, basically diagonally. There is like a rod here that's like this. There's like a hole on there. You put in the rod, you pull through the wire, you plug it in there, and you start to basically you pull it a bit back, because the wire can be fit right in here, but this inside diameter, this has a smaller diameter, as you can see, and the wire is going to be basically catching up on that. It will not be, basically the wound up wire will not be able to go through this. So as you push or pull this backwards, as you rotate this, as you rotate it and pull it backwards, you basically you stretch a bit, stretch the wire a bit, and also make it tighter. Basically tighten the winding, and they will basically just be next to each other, the wound wire coils. If you weren't to do that, you would be end up with a big gap in between them. They wouldn't be basically next to each other. So I have printed this out because I didn't have a right diameter for my job now. I have used previously to make smaller. I will get them. So this is how they look like originally when they been pulled out. I forgot to bring up there. I made a basically identical device, just they were smaller. So basically the outside diameter fit right into this one. On that, this is like I believe the inside diameter was 10, the outside was 15, and I have made that. This is like a 27 outside diameter, 22 inside. So because I haven't, this is how they started, and and I've made these basically bigger ones and stretched them a bit, basically heated them apart, pulled them with pliers, and they basically got a bit deformed, but they are kind of okay. They can function still as coils, and you can see on the color that they have been fired up because they have this bluish tint. I don't know how do they call this, but when you heat up steel to like 200 degrees Celsius or something like that, it gets blue. That's why it is. So these were the first prototypes. I cannot really show you the bigger one because yeah, you can like wonder if this is this big, then how big this is. And this got to be like 27. I fucked it up a bit because so designed to be able to hold 3 stages, but actually you put this in and you wind it up. There's like a tension in here. When you basically unlock this tension, this will spring back because of the force that is basically this inner resistance, this stiffness that these spring-like coils have. Basically these are springs. So these springs have, they will like turn it back on, and they get bigger because they get loose, and basically they are like this when they are tightened, and when you allow them to spring back, they basically twist back and they get bigger in diameter. And it's a bit tricky to pull out from this jig, but it can be done with a bit of like trying. And also it gets bigger, so I wanted to fit in 3. Basically I aimed to have a inside the diameter of the coil, so this to be set to 2022, because that would be able to house these catalysts. These are 10 millimeter outside diameter quartz tubes in a triangular shape arrangement. So basically here, like so, and there would be the coil around them. But that didn't really work out, so it instead of 22 it got to be 27. But actually this is not that bad, because now I got to fit in not 3 but 4 actually. So this is able to house 4 in a hexa, or not hexa, what is this? It's a square arrangement. So the square has that, and the outside there is the thing, the wire. So this is the 27 millimeter inside diameter as advantage, basically, that I can fit 4. I've been working with basically the sulfur burner. This is the chamber, as I said, and pumped it through the catalyst bed into the bubbler, and then out to the scrubber. This is the bubbler. So basically I have made a better bubbler than the previous week. Use the Vuitton tubing that I had, and probably will tour you tomorrow. I will test out the waiting times yet again, because I have changed as I said, wound a new coil, so the resistance changed, thus the power that it draws, and this is now the 140 watts that I've been talking about. It was previously 190, 200, 240, whatever. So these are actually 240 watts because these are smaller, have less resistance, thus they provide higher power. But the bigger has like a better heat capacity. Basically it holds heat better. The chamber here burned the sulfur, and the burning sulfur, if you don't know it, is liquid. It's like a, how do they usually draw it? Like this. This is like a liquid here, that this sign shows it. So this liquid is then pumped with air. So this is the closed vessel. The air comes in here, and here it burns, and SO2, SO3, and SO, all this bullshit go out. The problem is that the air is cold, and the sulfur will cool out and thus solidify, which will basically slow the reaction, the burning, and basically this flames with a beautiful blue flame. And the problem is, when it solidifies, it doesn't really burn anymore. So for this reason, I wanted to put in a preheater. The problem was that I needed to come up with another type of heating solution, which I did. I have found a hairdryer, but the wire was too thin, and basically it blew the fucking relay off, and I had to just ditch that solution. So I tried to, or at least thought to myself that maybe I will use two of these to heat two pipes up. Basically I wanted to have two stages there, and well, I can do another one of these and then I can use that, or maybe I can use the Kanta wire that I have wound and use that to that, because these two are identical or at least similar. Basically they differ like in 4 watts of power draw from each other, so I don't need to change anything up with the timing and all this stuff. So these two can have the same amount of heat basically with the same timing, so I don't need to change that. But here comes the fun part, because what I've been talking about is here that the good old transformer is probably not going to be. I didn't try test it out because I didn't want to melt it down, but like, if you think about it, even if I draw 240 watts with this, only one, this two is like 480 watts. 480 watts doesn't seem like much, but when it is on 6 volts, it's really a lot. So that's like more than 100, almost 100 amps. It's like 80 amps or something like that, so it's really significant. And that would fucking melt the wires I have. So for this reason, I have came up with this idea that I make a big coil and I put in 4 of these little quartz tubes, and they are not that little, they are 10 millimeters outside diameter. So this is where this comes in handy for this solution. The preheater is going to be a tube. Basically there will be 3 tubes for catalytic activity, and one tube for preheating. Basically what this means is that out of the 3 or out of the 4, 3 has like 3 is like this, and 1 is like these. It has these. I have made some alumina, from some electrocorund or some. Basically, I have like corund powder. That's like, if I'm right, maybe I'm not, but whatever. So this is basically corund, but this corund is used to be for some in the industry for sand blowing, basically to cleaning up. It's like sandpaper, basically, just you blow the air with, you have the compressor, you blow out air that picks up the sand like fine dust, and that basically cleans off surfaces. This is like the dust from your typical sanding paper. Basically that's like corund or some silicium carbide. But this is really 9 out of 10 on the most scale. Basically it's 1 step below diamond hardness. And on the other side, this is also very good because it is really heat resistant and chemically inert. Basically acids will not attack it, and also has like 2200 or something like that degrees Celsius of melting point. So aluminum oxide or corund or alumina, in this instance they call it alumina as well, alumina, it is really good. And I have made basically chunks. I have put some starch so this is like a really low-tech starch plus
alumina.
And I made them basically clumps into lumps. That was like brown, and it had like, it was like basically falling apart. I wrapped them with a big, basically made a few of these little stones. They're like like this big, and I wrapped them with an aluminum foil, and I put them into a fire. I fired them out basically, and when the starch burns out at like 600 degrees Celsius, they basically like sinter into a bead or something like this, basically into like a ball. I have collected them, and I'm going to put them into here. The alumina had some contaminants, so they get a bit rusty or whatever, but it's not that big of the deal, because the rest probably I'm going to attack them with some acid before I make the next batch. But what I've been wanting to say with this long fluff here is that I will put them into the quartz quartz tubing, and basically here is the like the I don't know, here's the next quartz tube. Here's the next quartz tube, and here's the wire. Here's the wire, and the wire will heat basically the 3 pipes up, or 4 pipes up. The 3 will have the catalyst, and the 3 will heat up. I will pump the air and basically circulate the, basically will update this, and we'll show you that later. But we'll update that, and here, before any of this happens, basically the first, I'll draw you a new drawing, because this is like pretty shit now. So we have these 2, and let's draw like 2 another, whatever. So this is 2, and this is like, these are basically next to each other, but I don't want to confuse you that much. So this will have the air coming in from there, going through this, going into the chamber. Here's going to be the chamber. Here burns the sulfur. Then it goes into the dry air, basically. It has the calcium chloride that I've made. Basically, this is like, the blue is going to be air with sulfur. Then it goes out, goes into here, goes on to the catalyst bed, the first one. I'm gonna call this the first. Then it goes out, there it goes into the bubbler, the first bubbler. I made an updated bubbler, as I have said. I will show you that also as well. The bubbler 1. Then it will go basically into here. Let's say here. This is the second. Another bubbler here. Bubbler 2. Then from the bubbler it goes out again into the third one, into the third catalytic chamber. Then it goes out into the fourth bubbler, or third bubbler, sorry. So this is going to be the third bubbler, and then to the scrubber. So with this, I maximize the amount of this looks like all this stuff, but to cap it up, we pump. Here are the alumina chunks. These are basically here to have some thermal delay, and basically to store heat inside of them. When the coil heats these pipes up and tubes up, basically these alumina pieces will collect the heat and store them, and they will take longer to basically to cool off as well, and it is better to heat the air that's going through with this when there is like heat transition from the surface of the alumina pieces rather than just from the cylinder of the inside wall. So these are going to be heated from the coil here, and basically the air comes in first. It's heated on these little rock-like beads as the air passes through, and basically it will, because these are like in the way, it won't just go through, but it will have like circulations, and of course it will lead us to lose some pressure, because when it goes straight through it doesn't lose any pressure, but here there is going to be like circulations and I don't know the other names, but you get the point. The air will just make these turbulent circles, and it will lose some it will have some losses, and it will show us pressure loss. So goes in there, it is preheated, it goes into the chamber, and here I really hope it will produce at least like 200 degrees worth of heat in there. I mean, not like, definitely not like 200 degrees inside temp, but at least the air is going to be like 200 degrees, and I will lead a pipe almost right into the little pot, because it is in a little nickel crucible that I have and use. Basically that's filled with the sulfur. So the air is going to be pumped right into that, and the hot air, and then it's going to shoot through into the dryer where the calcium chloride is going to dry it and basically desiccant it, get all the air or almost all of the out of the hot gas, basically the moisture from the air from the hot gas. Then it goes into the first catalyst bed, into the bubbler, from the bubbler into the second catalyst bed, then into a second bubbler, third catalyst bed, into the third bubbler, into the scrubber. And this will take us hopefully into the conversion of like 80 to 95 percent of the burnt sulfur, but it will write it here. So this should, on theoretic levels, this should be able to convert 90 to what the fuck, like 90 to 95% of the SO, what up, SO2 into SO3. So that would be very, like this would be, sorry for the shake, this would be optimal, but I don't know, because there could be a lot of things that could fuck up. The heat is not right, or if the heat is right, then the flow rates are not right, the metavanadate is not converted fully, or I don't know. There could be tons of bullshit that could happen, but hopefully we'll see at least like an 80 or 90% of conversion in terms of sulfur dioxide into trioxide, and that will be visible both in terms of the fog that is generated in amounts, because the higher the conversion rates of this, the higher amount of the sulfur basically sulfur dioxide converted into trioxide, and the less the smoke is going to be. Because now when I've been tinkering around, I have made this work, and I don't know the amount of percentage that I have been able to convert it, but the problem was that first of all the sulfur basically cooled off and I couldn't run it longer than 5 minutes. The other thing was that when I even had two bubblers before the scrubber, basically had one that contained ammonia, or at least ammonium hydroxide, and then basically first water, then ammonium hydroxide, and then sodium hydroxide in the scrubber, and still even through that the sulfuric dioxide came through in the form of like white mist, and basically it made like smoke rings, like, you know, if you have seen the movie of Lord of the Rings, when Gandalf makes this like smoke rings, those basically, not joking, those came off the scrubber, which was kind of like amazing, but also like a bit disappointing in the sense that it didn't work as well as I intended, or at least it was not expected to work immediately, because I thought that with only one catalyst bed you can only like convert like 85-90% at max theoretical amounts. Even for me, the surface of the catalyst material and also the flow rates are not that good. I will have to tinker with the flow rates, have to come up with some 3D printed or maybe I will use some there are like this little fuel adjusting dials for like motor bicycles that have like adjustable, like, I don't know how to say, this is mechanically adjusted, and you can like close the fuel, and basically these are fuel valves. Maybe I will use one of those if I have somewhere around laying the, I could adjust the flow rate. I will come up with something like that, because the flow rate is really important. If you don't have enough air, that in basically chemistry is all about like ratios. If you don't have the proper ratio of air to sulfur, because you have, there is no such thing as too much air. There is so much. There is such thing as too little air here, because the air contains the oxygen, O2. This looks like another letter. So O2, oxygen contains around 20% of O2, 20 to 20%, and if we have very little O2, basically very little air, then the problem is going to be that we will not be able to convert all the SO2 to SO3, and also not even this doesn't happen, but the problem is that we need O2 O2 here to convert SO3, but there is like a catalyst which is, I like it, vanadium pentoxide V2O5. This is basically, when this is happening, it helps basically O2 plus vanadium pentoxide is going to make this sulfur trioxide, but also this is going to convert into V2O4, I believe, and this basically is redoxed back to V2O5 by oxygen. But this needs to this needs to regenerate, and to do that you need to be able to provide more oxygen than just the actual conversion needs. So this is why it is crucial to have a good flow rate. If you have too little flow rates, then that can cause it. So I will prep and swap out the current pump that I'm using. It will also have a higher pressure and also a higher flow rate, which is great, but probably I will need to cool it down, because it is like a little pump that can generate a ton of heat. So now I have been talking all of these, and tomorrow I will show you the actual setup. You will be a bit surprised on what I'm thinking about. Oh, as well, I am going to, as I said, the bubbler. I have made a video about it. If you didn't see, I think it was like titled something like absorption tower for home chemistry or something like that on my channel. Basically, I've made a dumbed down version of it, in that sense that I have drilled out the, talk about this, I have a jar, but this is not just a regular mason jar. This is like there's like a little mechanical lock on here, that so these can be locked, and there are like wires around it, so it can be like hand tightened. I will show you. I have drilled the top out. Basically, I will show you a top view. And 4 holes. Basically, one has the in, one has the out. for the gas, and also the other has the in and the out for liquid. What I mean by this is that I am going to have a peristaltic pump here that is going to circulate the inside water, or later on H2SO4, which is sulfuric acid. Sulfuric acid will be basically sucked from the inside and pumped back into here, and it will basically pump it right there. There will be like, I will redraw this for you for the sake of clarity. This will have a ton of like shattered glass in there that will fill up this, and the remaining liquid will be on this, so the volume of the liquid can be kept minimal and have a better, basically we have the same virtual volume, but the less liquid means that it can be higher concentration by less, basically we can make higher concentration acid faster. Basically we don't need to wait, I don't know, a day worth of work, but we can make smaller batches, and we can use them more rapidly and more readily. So these glass shards will have this, and when the water, and in the future they basically I start with water, then as the water picks up the sulfur trioxide, it converts into sulfuric acid, and basically from a low concentration of sulfuric acid it will gradually go up and up and up and up in concentration until it hits the point that it is like 100% sulfuric acid. Then it will take up SO3 even more, and then convert into, it's like H2SO, it's like H4SO8 or something like that, or 7, whatever, I don't know the chemical formula of oleum, but this is oleum. I will have the formula on screen. Probably will make this because this can be diluted up with water, and then that makes basically one part of this, one part of water gives you 2 parts of sulfuric acid. This is like 100% concentration, or like not 100% because that's like azeotropic, but like 98% or whatever the azeotropic bullshit is, limitless. Wanting to say, when the water or the sulfuric acid stream hits this, basically this is like this looks like this stream. This looks like this, basically like a tubular stream. It will splash all around, and as the gas wants to go up and out, it will collide with these little droplets that will have like a better conversion, because under here there will be like a bubbler that will bubble it through here, and it will go out and it will collide here. Yeah, this is it. You will see. This is what the system is looking like right now. Yeah, you can see there's a bit of anarchy right now, but yeah, this fucking rock wall has fallen over the place as I have been dealing with the tubes. So here are the tubings. So these are the 4 tubings. They stick all over the place. They used to be like stuck together like in this shape, but as you can see the pipes are like exerting some tension on them, so they are like falling all over the place, whatever. So you can see here's the sulfur burning chamber. The first of all, let's start. So this is this setup, because I have made a wrongful purchase in that sense. This is 24 volts, this is 12 volts, but I have only one 12 volt power supply. So I have a buck converter that steps down 24 volts to 12 volts. So I clamp the just it is clamped onto here because I only run this shit now, but when this will be working full on, I will clamp it here, the 24 volts, then it steps down to 12. The pump is powered, and also the peristaltic pump, we will talk about that later. So the pump pushes the air through this lead into the first quartz tube that is the furthest away there, that contains little alumina rocks just like these. So yeah, then it comes out, goes into the sulfur burning chamber, which is containing the little nickel crucible right there that has the sulfur inside. Then it goes out into the desiccant, into the calcium chloride containing chamber. This dries the air and the sulfur. Then it goes out into the first catalytic chamber that you can't see because of this fucking rock wool, whatever. Then there is inside the big coil, there is a as I have talked about, quartz wool that has the vanadium pentoxide. Then this is like a testing equipment that has a probe that measures the inside temperature that I read down from this multimeter. It's 14 degrees right now. So yeah, then it goes out, the sulfur plus the gas goes into this big jar. This looks kind of shitty, I have to wipe it off, but whatever. So it will contain water. This will be a big bubbler that will house the, basically this is the, down there it goes, it will have a bubbler just like this, and a very fine bubbler. The bubbles are coming up, and there's the peristaltic pump that sucks the water out and rotates it basically. Also it will sprinkle it down from the top, and as on the surface, basically in the water there will be little pieces of glass that will act as a like a volume filler, and also it will make a physical layer that will be able to catch the water, that it will this pump will like basically push it down in a jet stream or jet. Then on the surface of the glass it will break up, and it will contact and splash around and contact better with the bubbles that are coming out. So basically we react with the sulfur even more, pick up even more sulfur trioxide. So after that is done, this goes back into the if I'm right, no, this is it. So it goes back into there, then basically reacts on the catalyst again. This is like a second tubing. It goes into the first or the second absorber. This will contain water. Now it has some ammonium hydroxide. Then this goes back here, I believe. Yeah, I believe this goes back in here to the third catalytic chamber. It's the exact same thing, and it goes to the last final bubbler. Then when that is ready, sorry, this will be here. I just put it away because this will be hanging to this. This is a jar worth of sodium hydroxide, which is going to act as the scrubber. So this is the setup, fairly quickly told. I have told about the rest of the thing, but this was the overview.